Okay, so student, today we are going to see the numerical problem, that is your problem number 12. In that problem number 12, you have given the total energy of an body of mass 2 kg. So mass is given as a 2 kg. Performing SHM is 40 joule, means energy E is given as a 40 joule. Find the speed while crossing the center of the path. Center of the path means mean position. So you have to find the speed of that particle when it is crossing from the mean position. And at mean position, the velocity of a particle performing SHM is maximum, that is V max, which is equal to A mu. Means I want to find out the value of A mu. Clear? So now, I will write energy formula. Energy is equal to half m omega square A square. Omega square A square means instead of this omega square A square, I can put it here V max square, so it is half m V max square. Clear? So I'll write down the formula. V square max is equal to 2E upon m by cross multiplying. Here you are getting given the energy as a 40 joule and mass is given as a 2 kg. So this 2 factor will get cancelled. So what I will get? V square max is equal to 40. Means your V max is nothing but square root of 40 meter per second. 40 means what? This square root of 40 value will come in between 6 and 7. Because 6 square is 36, 7 square is 49. And this 40 value is in between 36 to 49. The square root of 40, if you see from the logbook square root table, you will get value of 40 is in between 6 to 7. Clear? Okay. Then, now we switch over to the next problem, which is nothing but the problem number 13. And in that problem number 13, you have given a simple pendulum performs SHM of period 4 seconds. So you have given the period of simple pendulum, that is capital T, is nothing but 4 seconds. That is given. And how much time after crossing the mean position will the displacement of the bob be the 1/3 of its amplitude? So displacement of bob x is nothing but 1/3 of that. And for that purpose, how much time is required? When bob is crossing from the mean position. So when bob will crossing from the mean position, displacement x is equal to a sine omega t, which you have already studied in the theoretical part. That is, when particle will start from the mean position, displacement x is equal to a sine omega t. Now instead of omega, I can put the value of omega, which is equal to nothing but 2 pi upon capital T into t. Or, it's okay. So now I am going to put the value. Value of x is what? 1 by 3a, which is equal to a sine into bracket 2 pi upon capital T. Capital T value is 4 into small. From both sides, this AA factor will get cancelled. So I'll get 1 by 3 is equal to sine inverse pi by 2 into 3. Because this 2 and 4 will get cancelled. So what I write here? Sine inverse 1 by 3 is equal to nothing but pi by 2 into 3. Is it right? This pi by 2, we have to convert. Pi value I will put as 3.142. So this 3.142 divided by 2 means I am getting here 1.57 into sine inverse 1 by 3 into 3. 1 by 3 sine inverse, so 1.57 sine inverse 1 by 3. 1 by 3 is 0. I will call it as 0.3333 into t is equal to t. And from your logbook, you have to see the angle from inverse table. Sine inverse. From that table, we can find out the angle, which is multiplied by 1.57. So you will get the value of, that is 10. Clear? Okay. Then the next problem is problem number 14. In that problem number 14, you have given the simple pendulum of length 100 centimeters. So the length of the simple pendulum L is given as 100 centimeters. This is given to you. Performs SHM. Find the restoring force acting on the bob of mass 50 gram. So the mass of the bob is nothing but the 50 gram. That is given. Then, when displacement from the mean position is 3 centimeters. So displacement is 3 centimeters. From where? From mean position. And at that time, you want to find out how much is the restoring force. So restoring force F is equal to minus Kx. This you want to find out. Well, what is value of K? K value is nothing but minus m omega square into x. Your omega value is nothing but minus m omega value is nothing but 2 pi upon t bracket square into t is nothing but the period of simple pendulum. So period of simple pendulum t is equal to 2 pi under root of L by G. And you have given that value of L is 100 centimeter. 100 centimeter means I can write down it is equivalent to 1 meter. So I'll put that value T is equal to 2 pi under root of 1 upon 9. This is nothing but the value of T. Clear? And now that value of T I can substitute in your force formula. So your force formula is minus m into bracket 2 pi. Instead of T, I will write the value of T as a 2 pi under root of 1 upon 1 divided by 9.8. Square of that into x. And now I can put all the values. Mass, which is in gram. Gram mass we have to convert into kg. So I'll write down here as a 50 into 10 raised to minus. So I'll write here 50 into 10 raised to minus into bracket. This 2 pi factor will get cancelled. 1 divided by square root of 1 upon 9.8. Square of that. So it will be multiplied by 9.8. And x value, x is in centimeter. Centimeter is to be converted into meter. So centimeter is converted into meter means it will become 3 into 10 raised to 1. And now I can do the multiplication. 50 into t, which is equal to 150. Multiplied by 9.8 multiplied by 10 raised to minus 5. And now you can do the multiplication. So 150 into 9.8. So 0, 15 into 8, which is equal to 120. So 0, again we have carry. 15 into 9, 135. 135 plus 12, which is equal to 147. Right? And this decimal point 1, so one decimal point is here, into 10 raised to minus 5 is 4. 4 means I will put it as a, got it? Or I can say that it is equal to 1.47 or same value I can write down here as the force value can be written as, here I write down, force value is 1.47. So decimal point is shifted to 3 digits into 10 raised to minus 2. So this will be the answer of your restoring force. So this is nothing but your restoring force value. Get it? Okay. So in the next lecture, I will take the next problem. Thank you. Bye.